All right, today on Technically EU, we are going to dive into network switching.
Absolutely. I'm ready. Let's get into it.
Yeah, network switching is one of those things that sounds kind of, well, a little dry at first, but another reading the stuff you sent over, wow, there's some seriously cool stuff going on behind the scenes.
I know, right? It's way more interesting than most people realize.
Yeah, did you know some switches can send power through the same cable as data?
Oh, yeah. Power over Ethernet or PoE. It's pretty amazing stuff.
PoE, right. And then there's this whole thing about spanning trees that prevent network traffic jams.
Yeah, spanning trees are essential for keeping things running smoothly.
Intrigue? I know I am.
So where should we start?
Well, I think a good place to start is just understanding what exactly a network switch is like. What does it actually do?
You can think of it as the traffic cop of your network.
A traffic cop.
Yeah, it connects all the different devices, your computers, your servers, printers, everything. In your home, that could include smart TVs, security cameras, wireless access points, and gaming consoles. And it makes sure all that data gets to the right place.
So it's more than just a connector?
Oh, absolutely. The key difference between a switch and a simple hub, like those old school things,
Yeah.
is that a switch doesn't just broadcast data to every device. It uses MAC addresses.
MAC addresses. Remind me, what are those again?
So each device on a network has a unique MAC address. It's like a hardware identifier for each device. And the switch uses those addresses to specifically direct the data only to the intended recipient.
So it's like sending a private message instead of shouting across a crowded room.
That's a perfect analogy.
So it's way more efficient and I guess more secure too, right?
Exactly. It makes things much more efficient and enhances security because data isn't going to places it shouldn't.
Okay, so that's a switch in a nutshell. But in the stuff you sent, it looks like there are different types of switches.
You're right, there are different types.
What are the main ones?
Well, one of the main distinctions is between layer 2 and layer 3 switches.
Okay, layer 2. Layer 3.
Yeah, it's all about how they handle data. Okay, layer 2 switches, they operate at the data link layer.
Data link layer.
Yeah, using those MAC addresses, to move data within a local network.
Oh, got it.
So they're like your local traffic directors.
Yes, layer 2 is like the neighborhood traffic cop. Okay, what about layer 3?
So layer 3 switches, they can do everything a layer 2 switch can, but they also have routing functions.
Routing, what does that mean?
So they can direct traffic between different networks.
So layer 3 is like the big picture traffic coordinator.
Yeah, handling the bigger picture.
Okay, I see it now. One of the things that really caught my eye was this PoE and PoE plus stuff.
Oh yeah, power over Ethernet.
It sounds very cool.
It's pretty amazing tech. It allows the switch to deliver both data and power over the same Ethernet cable.
Wait, so you're saying like I could power something like a security camera or something directly from the switch?
Exactly. No more separate power adapters.
No messing around putting things in walls and ceilings. That's amazing.
It can be a huge advantage, especially for things like security cameras or voice over IP or VoIP phones.
Yeah, it makes things a lot simpler.
And PoE takes it even further. More power for devices that need it.
More power, huh?
Like wireless access points and things like that.
It's like those mesh Wi-Fi systems everyone's using?
Exactly. You could power those right from the switch.
Wow, that's pretty convenient. So switches are doing way more than I thought. But speaking of all that data flying around,
Yeah.
how do they even manage all that? It's got to get kind of crazy, right?
You'd be surprised how orderly it is.
Oh, yeah? How so?
Well, there are different switching modes, and these determine how a switch processes and forwards all that data.
Switching modes. Okay, now I'm really intrigued. Tell me more about those.
Sure. One of the most common modes is called store and forward switching.
Store and forward?
Yeah. In this mode, the switch receives the entire data packet.
The whole thing.
Yes, and checks it for errors and then forwards it on to the destination.
So it's super thorough.
Exactly. That's the key here. Reliability.
But does that inspection slow things down?
You're right. It does add a tiny bit of delay because the switch has to process the whole packet first.
Okay, so it's like making sure a package is perfect before you ship it out.
Exactly.
So what about when speed is super important?
Then we have cut-through switching.
Cut through?
Yeah, in this mode, the switch starts forwarding the packet as soon as it reads the destination address.
So it doesn't wait for the whole thing?
No, it doesn't. It just starts sending it right away.
Okay, so is it like express delivery?
Pretty much.
But is that risky?
Well, there is a slightly higher chance of errors getting through.
Yeah, because it's not checking the whole thing.
Exactly. It's a trade-off, speed versus reliability.
I get it. So it's like sending out a package without inspecting it first. You might get it there faster, but there's a chance something could be wrong.
Exactly. A perfect analogy.
So is there a way to find a balance between the two?
Yes, that is called fragment-free switching.
Fragment-free, huh?
Yeah, this mode checks the first 64 bytes of the packet for errors before forwarding it on.
So it's like a quick quality check before shipping.
Exactly. It's a compromise between speed and error checking.
So it's not quite as fast as cut through, but it's more reliable.
Exactly. It catches the most common errors but still maintains decent speed.
Pretty smart. I'm seeing that there's a lot more to these switches than meets the eye.
There definitely is, and believe it or not, we haven't even touched on things like VLAN trunking.
VLAN trunking? Ooh, that sounds intriguing. Okay, well, let's dive into that next. Tell me, what are these virtual local area networks all about? It sounds like something straight out of like Tron or one of the futuristic movies.
Well, it's not quite science fiction, but it is pretty clever.
So tell me, how does it actually work?
Well, imagine you have a company, right, with different departments,
Okay,
and each department needs its own network with its own security.
makes sense.
VLAN trunking lets you create those separate virtual networks on a single physical switch.
So it's like having multiple lanes on a highway, each one for a different type of traffic.
That's a great way to put it.
So you wouldn't need a separate physical switch for every single department?
Exactly. One switch can handle multiple virtual networks.
And that's really efficient. But how does the switch know which data goes where?
That's where tagging comes in.
Tagging?
Yeah, so each data packet gets a tag that identifies which VLAN it belongs to.
Ah, so it's like a digital label.
Exactly, tells the switch exactly which lane to put it in.
So it keeps everything organized and flowing smoothly, even within that one switch.
Precisely.
This is pretty cool stuff. You know, earlier you mentioned some networking concepts. MAC addresses, and what about ARP or Address Resolution Protocol? Can you remind me what those are all about?
Sure, so remember MAC addresses are unique identifiers for each network card.
Like a fingerprint for each device, right?
Exactly, it's how the switch knows where to send the data.
Even in a super busy network?
Yep, even then.
Okay, what about ARP? How does that work?
So ARP, which I mentioned, stands for Address Resolution Protocol.
Okay.
And it's basically a translator.
A translator. What does it translate?
It translates IP addresses to MAC addresses.
Okay, wait, why does it need to do that?
Well, you see, devices on a network communicate using IP addresses. Those are like logical addresses.
Right.
But to physically deliver the data, the switch needs to know the corresponding MAC address of the device.
I see.
So ARP is like a directory that tells the switch which doorbell to ring.
ARP is like a phone book for the network.
Haha, yeah, digital phone book.
Okay, that makes sense. We also talked about spanning tree protocols earlier, and they sounded pretty important, like preventing network meltdowns.
They are.
So tell me, what do they actually do?
They prevent network loops, which can cause major networking problems.
Like network loops?
Yeah, imagine if data just travels in circles between 2 points on a network.
Yeah, it'd be like a digital traffic jam.
Exactly, and that could bring the whole network to a standstill. STPs make sure that doesn't happen.
Okay, so STPs are the cops directing traffic, making sure nothing gets stuck.
That's a great way to think about it.
Are there different types of STPs, or is it just one type?
Well, the original STP was a good start, but things have gotten more advanced.
I bet.
So we have things like RSTP now, Rapid Spanning Tree Protocol.
Wrap this so it's faster.
Yeah, much faster. Recovering from any network changes makes sense. And then there's PVST, which works on a per VLAN basis.
Per VLAN for each virtual network, so each gets its own traffic cop?
Exactly.
That's smart. The documents also mentioned RPVST and MSTP.
Oh, right. RPVST combines RSTP and PVST. So you get the best of both worlds.
So it's fast and efficient.
Exactly. And MSTP, multiple spanning tree protocol, that's even more sophisticated for managing those multiple VLANs.
So like a whole team of traffic cops coordinating everything.
Yep.
Pretty impressive how it all works together and we barely even notice it happening.
That's the goal.
You mentioned SFPs early in the discussion. What are those again?
SFPs are small form factor pluggable modules that you can use in switches.
Okay.
And they can give you different kinds of network connectivity.
So like one SFP for fiber optic, another one for regular RJ45 Ethernet.
Exactly. It gives you a lot of flexibility.
So it's like having adaptable ports on your switch that can connect to different types of networks.
Yeah, that's a good way to think about it.
Pretty handy. Wow, so far we've covered switches, directing traffic, virtual networks with VLANs, those STPs, preventing chaos. It's pretty amazing how complex it all is behind the scenes.
It is. But that complexity is what makes it all work so well.
Oh, so is there anything else we should know about network switching? Is there anything else lurking in the depths?
Well, there are two more things that are really worth understanding. EtherChannel and LACP.
EtherChannel and LACP. Okay, those are new ones. Hit me with it.
So remember how we talked about VLAN trunking being like having multiple lanes on a highway?
Yeah, each lane for a different virtual network.
Well, EtherChannel takes that concept a step further and bundles multiple physical links into a single connection.
So instead of one lane, you can have multiple lanes, like a super highway for data.
Exactly. It's all about maximizing bandwidth and making things super efficient.
That makes sense, especially for networks that have a ton of traffic.
Right. And that's where LACP comes in.
LACP?
Yeah, stands for Link Aggregation Control Protocol.
Okay.
It's basically the brains behind EtherChannel.
The brains?
Yeah, it dynamically manages all those bundled connections, makes sure everything is working properly, and, distributes traffic the right way.
So EtherChannel provides the extra lanes and LACP makes sure everything runs smoothly.
Exactly.
Pretty slick. Wow, this is great. But there's one more thing I'm curious about. Modular versus stackable switches. What's the difference between those two?
Great question. It really comes down to how you want to scale your network.
Okay.
So modular switches are like building blocks. You can add different modules for more ports or specialized features.
So it's like building a communication network from scratch, choosing exactly what you need.
That's it.
Cool. What about stackable switches?
Stackable switches, as the name implies, can be physically stacked together.
Okay.
And then you can manage them as a single unit.
So you just keep stacking them up as your network grows.
Exactly. It makes expanding your network super easy.
Okay, so if I want flexibility and customization, go with modular. If I need easy expansion, go stackable.
That's the gist of it. And this is why understanding all these different parts of networking is so important.
Okay, why?
Because it helps you make smart decisions about how to build your network.
So it's not just about knowing the tech, it's knowing how to use it the right way.
Exactly.
Wow. This has been a really insightful look into the world of network switching. I feel like I've learned so much.
I'm glad to hear that.
But I gotta ask, what's next? What other cool stuff is out there in the networking world? There's so much more we could explore, like routing protocols, network security, and wireless stuff.
Yeah, the list goes on and on.
True. It's really a whole universe of tech out there. But I think for now, let's bring it back to you, the listener.
Yeah, good idea. After all, what's the point of all this knowledge if you can't use it?
Right? So, thinking about everything we've talked about today, what does it all mean for your network? Now that you know a little more about how it all works,
Exactly.
what kind of switch would actually be best for your home or your office?
Yeah, it is something to think about.
Would you even need something like power over Ethernet?
Yeah, do you have devices that could use it?
Or what about VLANs? Would those be helpful for you?
Or maybe even EtherChannel if you've got a lot of traffic?
It's all about picking the right tool for the right job.
Exactly.
And now, hopefully, after today's podcast, you've got a better idea of what tools are out there.
Yeah. And even if you're not the one setting up your network, just knowing these concepts can help you talk to the people who are.
So you can be more informed and make better decisions about your network.
Exactly.
Man, this has been a really fun conversation. I feel like there is so much more to learn, though.
Yeah, but it's a good start on networking.
So thank you to you, the listener, for taking this deep dive with us. It's been awesome exploring and sharing this information with you.
Yeah, thanks for joining us.
And hey, who knows? Maybe we'll do another one on networking equipment.
Sounds good to me. Until then, keep learning and keep those networks humming.
Couldn't have said it better myself. See you next time.